Okay, we're going to solve number 17 from chapter 9, and that's basically finding x cubed equals 6x plus 6, and we're finding the solution. And so you have to put it in, to use Cardano's formula, which is what we're going to use, you have to put in the standard form that's already in. X cubed equals cx plus d, and it's already matches the form. As you can see, c in this case equals 6, and d is also equals 6. So Cardano's formula states x equal to, it's a very big long formula, d over 2 minus square root of d over 2 squared minus c over 3 cubed. And so we're going to plug in these numbers according to the formula, and we're going to get 6 over 2 plus 6 over 2 squared minus 6 over 3 cubed plus the cube root of 6 over 2 minus 6 over 2 squared minus 6 over 3 cubed. And if we simplify even further, we're going to get 3 plus the square root of 9 minus 8 plus the cube root of 3 minus square root of 9 minus 8. We're going to get x equals cube root of 4 plus cube root of 2. And so this is pretty simplified, it's relatively simplified. And that's actually our answer. Surprisingly, how this relates to modern math is that actually we don't have a better way to solve cubic equations. This doesn't work for everything, because as you see, for this form to work, there's no x squared term. You would have to do something different for that. But that just shows, Cardano's from the 1500s, and to this day we still do not have a better method. When we are faced with a cubic equation, even today in modern math, we don't have one verifiable go-to way to solve the problem. Instead, we have to use a bunch of different ways. And so Cardano's formula is still a type of formula that we use to this day when we're faced with an equation that, that's in this form. And there's other things like the factor theorem and stuff like that, but that's only if the roots happen to be round numbers, integers. And as you can see here, that this solution, which is the only real solution to this equation, is not a clean, easy solution. So we have to use Cardano's formula, and it's just interesting to note how 500 years later, we still use what he discovered today.